Download this code from codegive.com, link in the description below. OK, let's dive deep into testing vapi.ai callers, ensuring they perform flawlessly and deliver a fantastic user experience. This will be a comprehensive guide covering various testing strategies, code examples in Python, using pytest, and best practices. Introduction: why testing vapi.ai callers is crucial. Vapi.ai, or its successor platforms, depending on your use case and the provider you're using, allows you to build conversational AI applications that integrate with phone systems. These applications handle voice interactions, respond to user inputs, and potentially connect to other services. Therefore, thorough testing is absolutely vital for several reasons. Ensuring accuracy. You want to verify that your caller correctly interprets user speech, extracts the intended information, entities, intents, and responds appropriately. Incorrect interpretation leads to frustrating experiences. Handling unexpected inputs. Users won't always follow the ideal script. You need to test how your caller deals with unexpected phrases, noise, interruptions, or incomplete information. Robust error handling is crucial. Validating business logic. Vapi.ai callers often interact with backend systems. You need to verify that these integrations work correctly, ensuring data is fetched, updated, and processed as intended. Performance and scalability. As your application grows, you need to ensure that the caller can handle increasing volumes of calls without performance degradation. This includes latency and response times. Regression testing. When you make changes to your caller's logic, training data, or backend integrations, you need to run regression tests to ensure that existing functionality remains intact. Improving user experience. Ultimately, the goal is to create a seamless and intuitive voice experience. Testing allows you to identify areas where the conversation flow can be improved or where users are likely to encounter difficulties. 2. Types of tests for vapi.ai callers. We can broadly categorize tests for vapi.ai callers into the following types. 1. Unit tests. Focus, testing individual components or functions within your caller's logic, example intent handlers, data validation functions, API calls. Advantages: fast, isolated, easy to debug. Example, testing a function that validates a date entered by the user. 2. Integration tests. Focus, testing the interaction between different parts of your system, such as the vapi.ai agent and your backend API. Advantages, verifies end-to-end workflows, catches integration issues. Example, testing the flow from user utterance to vapi.ai intent recognition to API call for data retrieval. 3. End-to-end, E2E, tests. Focus, testing the entire call flow from start to finish, simulating a real user interacting with your caller. Advantages, verifies the complete user experience, identifies system-wide issues. Example, testing the entire onboarding process, from welcome message to account creation. 4. Performance tests. Focus, measuring the response time, throughput, and resource usage of your caller under load. Advantages, identifies bottlenecks, ensures scalability. Example, simulating multiple concurrent calls to the system and measuring the average response time for key actions. 5. Acoustic tests. Speech recognition tests. Focus, evaluating the performance of speech-to-text (STT) engine with different accents, background noises, and speaking styles. Advantages, checks the accuracy of intent recognition under real-world conditions. Example, playing recorded audio samples with varying levels of noise and analyzing the accuracy of the recognized text. 3. Setting up a testing environment. 1. Choose a testing framework. Will use pytest in Python, a powerful and flexible testing framework. 2. Install dependencies. Install pytest and any other libraries you'll need, example requests for making API calls. 3. Mocking and stubbing. During unit and integration tests, you'll often need to isolate your components by mocking or stubbing external dependencies like APIs or databases. Pytest has excellent support for this. The unitest.mock module in Python's standard library is also helpful. 4. Create test files. Organize your tests into separate files, typically named test_star.py, example test_intent_handlers.py. 5. Configuration. You might want to set up environment variables or configuration files to store API keys, database connection strings, and other test-specific settings. 4. Unit testing. Example, intent handler validation. Let's say you have a function that handles the get weather intent and validates the city name. Here's the unit test. Import pytest. Imports the pytest framework. From weather_handler import validate_city, handle_get_weather. Imports the functions you want to test. Test_validate_city_valid. This is a test function. Pytest automatically discovers functions starting with test_. Assert. This is an assertion. If the condition is false, the test fails. To run these tests, integration testing. Example, vapi.ai and backend API. This is more complex. Let's outline the general approach. We'll need to mock the actual vapi.ai interaction or use a test account with vapi.ai that has limited capabilities and doesn't affect the production environment. Assume you have a function that calls a weather API based on the city from vapi.ai. Here's an integration test example that mocks the requests library. *at patch, weather_API_client.requests.get. This is a decorator that replaces the requests.get function in the weather_API_client module with a mock object. *mock_get*. This is the mock object. You can configure it to return specific values or raise exceptions. *mock_get.return_value.status_code equals 200. Sets the status_code attribute of the mock response object. *mock_get.return_value.json.return_value equals sets the return value of the JSON method of the mock response object. 6. End-to-end E2E testing. E2E testing for voice applications is the most challenging, but also the most valuable in terms of ensuring user satisfaction. Here are the common approaches. 1. Manual testing with real users. This is essential. Have real people interact with your caller and provide feedback. Focus on usability, clarity, and overall experience. 2. Automated speech testing tools. Some tools allow you to simulate phone calls, provide audio input, using pre-recorded audio files or text-to-speech, and verify the responses from your vapi.ai caller. You'll need to research tools that are compatible with the specific vapi.ai platform you're using. Unfortunately, there isn't one single dominant tool for all vapi.ai-like services. 3. Using telephony testing APIs. Some telephony providers offer APIs that allow you to programmatically make and receive phone calls. You can use these APIs to automate parts of the E2E testing process. E2E testing considerations asterisk. Asterisk test data asterisk carefully design your test cases to cover various scenarios, including edge cases, error conditions, and unexpected user inputs. Asterisk assertion strategies asterisk develop clear assertion strategies to verify that the call flow is progressing as expected and that the correct information is being exchanged. Asterisk environment management asterisk ensure that your testing environment is properly configured to simulate the production environment. Asterisk logging and debugging asterisk enable detailed logging in your caller so that you can easily diagnose issues that arise during E2E testing. Example, conceptual, using a hypothetical telephony API. 7. Performance testing. Performance testing is vital for ensuring that your vapi.ai caller can handle real-world traffic. One load testing asterisk simulate a large number of concurrent calls to your system to measure its response time, throughput, and resource usage. 2. Stress testing asterisk push your system beyond its limits to identify breaking points and determine how it behaves under extreme load. 3. Monitoring asterisk use monitoring tools to track key performance metrics such as CPU usage, memory usage, and network latency. Performance testing tools asterisk. Asterisk Locust asterisk a Python-based load testing tool. Asterisk Gatling asterisk a Scala-based load testing tool. Asterisk JMeter asterisk a Java-based load testing tool. 8. Acoustic and speech recognition testing. This testing aims to improve the accuracy and robustness of your speech recognition. 1. Collect audio samples asterisk gather a diverse set of audio samples that represent different accents, speaking styles, background noises, and devices. 2. Record audio in realistic environments asterisk if possible, record audio in the types of environments where your caller will be used, example noisy office, quiet home. 3. Analyze speech recognition accuracy asterisk compare the transcribed text from the speech-to-text engine to the expected text. Use metrics such as word error rate, WER, to quantify accuracy. 4. Adjust speech recognition settings asterisk experiment with different speech recognition settings, example language models, acoustic models, noise reduction, to optimize performance for your specific use case. 5. Implement error handling asterisk design your caller to gracefully handle cases where speech recognition fails or produces incorrect results. 9. Continuous integration and continuous delivery, CI/CD. Automate your testing process as part of your CI/CD pipeline. This will help you catch issues early and prevent them from reaching production. 1. Integrate tests with your build process asterisk run your unit and integration tests automatically whenever you commit code. 2. Automate E2E tests, where possible run your E2E tests on a regular basis, example nightly, or whenever you deploy to a staging environment. 3. Use a CI/CD tool asterisk popular options include Jenkins, GitLab CI, Circle CI, and GitHub Actions. X. Best practices. Asterisk write clear and concise tests asterisk make sure your tests are easy to understand and maintain. Asterisk test-driven development, TDD consider writing your tests before you write your code. This can help you design better code and ensure that it is testable. Asterisk use descriptive test names asterisk choose test names that clearly describe what the test is verifying. Asterisk keep tests independent asterisk make sure that your tests don't depend on each other. Asterisk use mocking and stubbing appropriately asterisk isolate your components by mocking or stubbing external dependencies. Asterisk document your tests asterisk explain the purpose of each test and how it works. Asterisk regularly review your tests asterisk ensure that your tests are still relevant and effective. 11. Conclusion. Testing vapi.ai callers thoroughly is essential for delivering a high-quality user experience. By employing a combination of unit, integration, E2E, and performance tests, you can identify and fix issues early in the development process and ensure that your caller performs reliably and accurately. Remember to automate your testing process as part of your CI/CD pipeline to catch regressions and maintain code quality. Good luck! Okay, let's dive deep into testing vapi.ai callers. This guide will cover various aspects, from basic unit tests to more advanced integration and end-to-end testing strategies. We'll include code examples in Python, as it's a popular language for AI and API interactions. Introduction: why is testing crucial for vapi.ai callers? Testing is paramount when working with vapi.ai callers for several compelling reasons. Reliability and accuracy. AI-driven systems can be unpredictable. Testing helps ensure that your callers respond as expected across different scenarios, providing accurate and consistent outputs. Error handling. You need to verify that your caller gracefully handles errors like network issues, invalid input, API rate limits, or unexpected responses from the vapi.ai service. Robust error handling prevents application crashes and provides informative feedback to users. Performance. Performance testing ensures your callers can handle expected loads without latency spikes. Slow response times from a caller can degrade the user experience. Maintainability. Well-written tests serve as documentation for your code and make it easier to refactor, update, and maintain your vapi.ai caller in the long run. You can make changes with confidence knowing that existing functionality won't break. Security. Testing helps identify potential security vulnerabilities, such as improper data handling or authorization issues when interacting with the vapi.ai API. Regression prevention. As you evolve your code base, tests prevent introducing regressions, i.e., breaking existing functionality when adding new features. 2. Testing strategies for vapi.ai callers. We'll explore various testing levels, starting with the most granular and moving to more comprehensive approaches. 1. Unit testing. Focuses on testing individual units of code, functions, classes, or methods, in isolation. The goal is to ensure that each component performs its intended task correctly. 2. Integration testing. Tests the interaction between different components of your system, such as the vapi.ai caller and other modules within your application. 3. End-to-end, E2E, testing. Simulates a user's complete journey through your application, verifying that all components work together seamlessly from start to finish, including interaction with the vapi.ai service. 4. Mocking and stubbing. Critical techniques for isolating your code during testing, especially when dealing with external APIs like vapi.ai. Mocks replace external dependencies with controlled, predictable responses. 3. Setting up your testing environment. Before writing tests, you need to establish a suitable testing environment. Here's how to do it with Python. 1. Install pytest*, a popular and powerful testing framework for Python. 2. Install requests*, if your vapi.ai caller uses the requests library to make HTTP requests, common practice. 3. Install responses, or mock for mocking API responses during unit tests. Responses is generally more user-friendly for API mocking. Alternatively, you can use the built-in unitest.mock library. 4. Project structure*, a good project structure helps organize your tests. 4. Unit testing with mocking, example. Let's assume you have a vapi_caller.py file with the following code. Now, create a test_vapi_caller.py file to test it. Explanation*. Asterisk fixtures asterisk the vapi_caller fixture creates an instance of your vapi caller class with a dummy API key. This avoids hard coding the API key in each test and makes your tests more maintainable. Fixtures are a powerful pytest feature for managing test dependencies. Asterisk add responses.activate asterisk this decorator enables the responses library, which intercepts outgoing HTTP requests and allows you to mock the API response. Asterisk responses.post asterisk configures the mock API response. You specify the URL to match, the JSON payload to return, and the HTTP status code. This simulates the vapi.ai API's behavior without actually making a network request. Asterisk assertions, assert, checks that the actual result of your code matches the expected value. If the assertion fails, the test fails. Asterisk error handling asterisk the test_generate_text_API_error function tests how your code handles API errors. It uses pytest.raises to assert that an exception is raised when the API returns a 500 status code. The exception message is also checked to ensure it contains the expected error information. Asterisk test_generate_text_invalid_API_key asterisk this test simulates a 401 unauthorized error, invalid API key. Asterisk test_vapi_caller_no_API_key asterisk this checks the constructor of the vapi caller class raises a value error when no API key is provided, either as an argument or through the environment variable. It also safely unsets and restores the environment variable to avoid affecting other tests or the system's environment. Running the tests asterisk. Open your terminal, navigate to the my_project directory, and run. Pytest will execute the tests and report the results. Integration testing. Integration tests verify that your vapi.ai caller works correctly with other parts of your application. For example, you might test how the caller integrates with a message queue, a database, or a user interface. Example asterisk. Let's say you have a function that uses the vapi caller to generate text and then saves the result to a database. Here's an integration test for this function. Explanation asterisk. Asterisk clean_database fixture asterisk a fixture to create a clean database before each test and remove it afterwards. This prevents test data from interfering with each other. Asterisk database path asterisk always use a different database path for testing than your production database. This prevents accidental data corruption. Asterisk mocking asterisk the responses library is used to mock the vapi.ai API, just like in the unit tests. Asterisk verification asterisk the test verifies that the save_generated_text function correctly calls the vapi.ai API, saves the generated text to the database, and returns the expected result. It also checks for the case where vapi.ai returns an error to ensure that the integration deals with this correctly. 6. End-to-end, E2E, testing. E2E tests simulate real user interactions with your application. They typically involve running your application in a test environment and using tools like Selenium, Playwright, or Cypress to automate user actions. E2E tests with external APIs like vapi.ai may be too costly in the long run and require special considerations such as limiting the number of test runs, e.g. running these tests nightly. Using mocks and stubs as much as possible. Using a smaller LLM that costs less, but is representative of the model used in production. Here's a conceptual example using Selenium, simplified. Important asterisk. UI setup asterisk this example assumes you have a web application with elements like a prompt input field, prompt input, and a generated text display area, generated text. You'll need to adapt the locators, by.id, etc., to match your actual UI. Chrome driver Selenium requires a driver, like Chrome driver for Chrome, to interact with the browser. Make sure you have it installed and configured correctly. Application URL replace http://localhost 5000 with the actual URL of your running application. 7. Mocking versus stubbing. Mocking involves creating a complete replacement for a dependency. Mocks are often used to verify that specific methods were called with the correct arguments. The responses library provides a convenient way to create mocks for HTTP requests. Stubbing provides a simplified version of a dependency that returns predefined values. Stubs are typically used to control the behavior of dependencies without verifying specific method calls. In the examples above, we primarily used mocking with responses because we wanted to control the exact API responses and simulate various scenarios: success, error, invalid API key. 8. Important considerations. API keys never hardcode API keys directly in your code. Use environment variables or configuration files to store sensitive information. In tests, use dummy API keys and mock the API responses. Rate limiting. Be mindful of API rate limits. If your tests make too many requests to the vapi.ai API, you might get rate limited. Use mocking to avoid hitting the API during most tests. Consider running a limited number of integration or E2E tests against the real API to verify end-to-end functionality. Test data. Use realistic but safe test data. Avoid using sensitive or confidential information in your tests. Test doubles. This is a broad term encompassing mocks, stubs, spies, and other techniques for replacing real dependencies in tests. Understanding the different types of test doubles can help you choose the right tool for the job. 9. Continuous integration, CI. Integrate your tests into your CI/CD pipeline. This ensures that your tests are run automatically whenever you make changes to your code, providing early feedback on potential issues. Popular CI/CD tools include Jenkins, GitLab CI, GitHub Actions, and Circle CI. Conclusion. Testing vapi.ai callers thoroughly is essential for building reliable, accurate, and maintainable AI-powered applications. By combining unit, integration, and E2E testing strategies, along with mocking techniques and careful attention to API key management and rate limiting, you can ensure that your callers perform as expected in a wide range of scenarios. Remember to continuously refine your testing practices as your application evolves.